binary release, and it will bring you to this page. Now, depending on what operating system you're on, you're going to click on something different than I may be clicking on. You know, if you're on Linux 32-bit or Linux 64-bit, you're going to be looking at these boxes right here. If you're on Mac OS X, you're going to want to scroll all the way to the bottom, and they have a download link right here. Me though, I'm on Windows 7, so I will come up here, and if you look, it doesn't say Windows 8 right here, but up here it says Windows, 7-8. So these binary builds should work on Windows 8 and 8.1. In fact, I've actually downloaded it on Windows 8 and 8.1, so I know for a fact it will work. If you look over here, there are two different links. There's BurleyOS and SourceForge.net. I'm not that familiar with BurleyOS, but I am familiar with SourceForge, and I use it for a lot of my downloads, so I would recommend using SourceForge.net. Now, there are three different types of binary releases that you can download. Now, when I first started programming, my instructor had us download this binary release right here, the second one on the list, which is perfectly fine, works great. But as I got into more advanced C++ programming, where I started doing concurrent threads and different kind of concurrent thread processing, multi-threaded processing, I needed this GCC 4.8.1 for my code blocks to work with threads. It's a specific compiler. So I would recommend, if you plan on going more in depth with C++ and maybe taking a course after this, to go ahead and download this one, because if you start getting into threads in C++, you will have to come back and download this compiler right here for code blocks to work. Otherwise, this right here is a great option as well. So either one is fine for this course. You're going to want to go ahead and click on SourceForge.net to continue on either one of the links. I'm going to click on the second one. It will take you to SourceForge.net, and the countdown will begin for your download. And after the countdown, the exe file should be downloaded. We'll give it a second. And right down here, you can see codeblocks 13.1.2.exe. And it says there's still, 9-10 minutes left before it's done downloading on mine, so it might take a while for it to download. I'm not going to sit through this tutorial and wait for it to finish downloading, simply because I already have it downloaded on my computer. But I will tell you, when it does finish downloading, you're going to want to launch the exe file, and a install wizard will pop up. And it's a very simple install wizard. Basically, you just click next on every single pop-up window, and it should install very easily with no problems. After it's done installing, you're going to want to search for the program, either by using your search like this, or it might have even put it in your taskbar like I have it right here, and it might even have a desktop shortcut. Whatever the case, you're going to want to launch code blocks. You'll give it a little bit of time, especially on the first time launching it. When the first time you launch it, it might take a little bit longer than you expect. Also, though it seems like it's taken a while for it to download on my computer, my internet connection is quite slow right now. I just moved, and I have slow download speed as of right now because I haven't yet upgraded my internet. So that at your house, it'll probably go a lot faster than mine. I think I have like 8 megabit download speed right now. This is what's going to pop up when CodeBlocks launches, and in the next tutorial, we are going to create a new project, and we will discuss the Hello World project that will be created, and discuss the anatomy of our very first C++ program. So stay tuned, and I'll see you in the next tutorial. So if you open up Code Blocks, you're going to want to click on Create a New Project, and then click on Console Application. On mine it's in the top right corner of the window. On yours it may be different, but you want to click on Console Application and then hit Go. Then on the next window you want to hit Next until you get here. Make sure you highlight C++, click Next again, and then give your project a name. And mine, I'm just going to call it Tutorial 1, and then specify a folder to keep it in. Make sure it's a folder that you can find easily, and then click Next. Leave all the default settings on this window right here. These are simply directory and compiler settings. Just hit Finish, and then your project is created. So right now you don't see anything, but if you go over here to the left and click on Sources, you'll see the main.cpp file, which stands for main.c++. And if you double click it, you'll see the code. Now before we analyze this code, I want to go ahead and show you how to run it and what this code does. And to do that, on Windows you can either hit F9, or if you're on a Mac or Linux machine, you can just go up here and hit Build and Run. The code will compile, and then you'll see this console window. It prints the word Hello World, and then says process returned 0. Okay, so you can close out of this. Now that we know what the code does, we're going to look at how this code does what it does. So beginning with, kind of the main thing I want to show you in this tutorial, other than how to run your first program and compile it, is how to type out the skeleton of a C++ program. It's what I call the skeleton, and it's everything that you need for your code to run, at least in this course anyways, for every program that we will be writing together. So if we go ahead, I want to go ahead and take out this line, because this line is not actually needed for this program to compile and run. So if we take it out and we hit F9 and we build and run it again, we will get the process returned to 0. We just won't have Hello World printed to the console, which means, that's fine. The program just ran and executed till it finished with no errors, and it's a perfectly good program. So if we exit out of this, we're going to now analyze everything that we need, which is everything that you see right here. So starting from the top, you're going to see pound include IO stream. This line of code right here just simply tells the program that it needs to include a C++ library known as IO stream, which stands for input output stream. Now in every program that we write, you will need this line of code, which is why I include it in our skeleton. It's because if you don't have this line of code, your program will lose its basic input and output functionality. So you do need this line of code in every program that we write. Moving on, you're going to see using namespace standard. Now this line of code is not necessary for your program to run. Okay, so if we took this code out right now, it should still run fine. If we hit F9, everything goes fine, and we still get the same result, process returned to 0. However, I do want this line of code in here for reasons that I'll explain in the future. For now, just know that we do want to include it as part of our skeleton, because it will make your life easier when we start writing more code, and I will show you why in future tutorials. But for now, just know that you do need using namespace standard semicolon. Okay, and it does end with the semicolon. Now, I know right now you're saying, why does this line of code end with the semicolon and this one doesn't? Well, we'll get to that in future tutorials. Again, it's all going to become a habit. For now, just know this is the code that you will need in all of our C++ programs. Moving on to the next big chunk of code. This right here is known as your main function. And in every C++ program that we write, you will need a main function. And to type it up, you just simply write int, which stands for integer, and then main, open parentheses, close parentheses, and then your brackets with the return 0 statement.
Now in programming, there's two different conventions for writing these brackets. I want to go ahead and show them to you now so you don't get confused later if I do this. One convention is the way you just saw it, which is like this, where your brackets are open and closed down here. But the other way you may see it is like this, where your brackets open at the top and closed down there, which is fine. There's no difference in the code whatsoever. It will run just the same. So just know that it's just a programming convention. There's no right or wrong ways. Some people have their own opinions on why they do it a certain way, but just know, it's all a matter of preference. So before we end this tutorial, I want you to go through and I want you to type this up with me so you can get in the habit of doing it. So what's the first thing we need to do? Well, we need to include the input-output stream C++ library so that we can, output stuff to the console window. To do that, we're going to hit pound include IO stream. Okay, no semicolon on this line. Again, we'll get in the habit of knowing where to put them and where not to put them. But for now, just know there's no semicolon at the end of this line. Now, though we don't need it for this program, you do want it as part of your skeleton for this class. I do want you to get in the habit of writing it in all of our programs. So let's go ahead and do it now. You want to use the standard namespace. And how do we do that? Remember, we typed using namespace standard. And that one did have a semicolon. Moving on, the other really critical piece of code that we need for our program to run is the main function. And remember, that was preceded with int, which stood for integer, the name of the function, main, open parentheses, close parentheses, and then our brackets, depending on what convention you decide to use, will be different. And then return the value 0. This right here is working code. If you take out some of this code, such as that, this code will return an error. It will not run. So for now, just know that everything in this code is needed, and in future tutorials we will go into a discussion as to why they are needed and what exactly they do. Before we get into the code blocks editor, I kind of want to do this on a notepad sheet real quick so that we can show you. I want to kind of discuss with you how these data types are declared and what they mean. So a data type, what is a data type? What is a data type? A data type is basically a description of what we are using. So for instance, in the real world, if we were going to use the letter B, for instance, well, this is, to us, is known as a letter. This would be the data type in programming. Okay? Or what if we were talking about the number 7? Well, in our world, this is just called a number. This, again, is a data type. And, if we were talking about programming. Except in programming and in C++, we don't call them letters and numbers. So, what do we call them? Well, let's start with just a single letter. Let's just start with the character B. Okay, again, this is just a letter, but in programming, this is called a character data type. And the character data type, sorry about that, the character data type is denoted or kind of encapsulated with single quotation marks, as so. So that's how, so in C++, this letter B is called character data, and you have to declare it with single quotation marks. And when we get into example code, you'll understand what I mean by declare with single quotation marks. But let's move on to a number. So let's say 7. In C++, this is called an integer. And an integer is denoted just as it's seen. No quotation marks, nothing special. What about multiple letters though? You know, what about, you know, the name Bill? You know, that's 4 characters, but this thing is a whole. What is it? Is that a word? You know, in our world it's called a word, but what is it? What is it in C++? Well, in C++, it is known as a string, which is alphanumeric data. Okay, but for now just know it's called a string data, and you denote string data with double quotation marks, as so. Okay, now I kind of want to go over one last thing, and that's decimal numbers. So like 7.77, you know, is that an integer? Well, no, it's not, because it's not a whole number. So what is that called? Well, in this, it can be one of 2 things. You know, actually it can be multiple things, but for this course we're going to keep it simple. Know that it's either a float or a double. Okay, and it's denoted just as 7.77. For this class we're going to use the word double, and the reason why is because if you use the word float, when you declare it as this 7.77, behind the scenes in code blocks automatically converts it to a double anyways. So for now we're just going to call it a double data type. Okay, so let's move on to some actual code. Okay, and we're going to practice declaring these 4 major data types that I've shown you here. So let's open up our code. And by the way, in the last tutorial the code was, I zoomed in if you couldn't tell, if it was hard for you to read in the last tutorial. Hopefully this will make it easier for you to read. So right now let's go ahead and practice what we learned in the last tutorial in this project. I want to practice writing our skeleton, so to speak, everything we need for our code to run. So we need to do basic input and output library. We need to include it. So let's include IO stream. Okay. We want to use the standard namespace. Okay. And then we need to declare our main function. And we need a return value for this main function, which, as we said, we're going to use 0. And this is our skeleton. This is everything we learned in the last tutorial. Again, if you still haven't got this down yet, you know, I suggest just practicing it over and over until you get it down to where you can basically write this code in your sleep to get your program to compile and run as so, with process return 0. But let's get into our data types and variables. Okay, so we discussed what the data types were. You know, it's kind of a description of what you're dealing with, but what's a variable? Well, a variable is kind of like a box, and your data type is a label on that box. That's how I want you to picture this. So you have a box, and then you have a label on this box. Okay, so let's say we put the letter B inside a box. Okay, so the letter B is character data, right? We discussed this earlier. So to declare the character data, we write CHAR, which stands for character. Okay, so that's our label, character, CHAR, that we're putting on our box. Now our box is user defined, meaning we can name it whatever we want. So I'm gonna name it letter, because that's what's in this box, is letter. It's a letter, okay? And then we need to declare what the letter is, so we put a equal sign. I'm sorry about that, guys. I don't know what that is popping up. So you put an equal sign, okay? And then, again, character data is denoted with single quotation marks. And then inside the single quotation marks, we put our letter B. And then end the statement with a semicolon. And this right here is declaring a variable with the data type of character. And that variable, that character variable, is the letter B. Okay? So let's move on. Let's move on to the other. Now, if you don't know what this is used for yet, that's fine. In the next tutorial, we're going to discuss how we use these variables and what exactly they're used for. But for now, we're just declaring them, and I'm kind of giving you a visualization of what they are. Okay, so just for now, think of them as a box with a label and then something inside the box. In this case, it's a box that holds characters, and in the box is the character B. Okay? So let's move on to a number, a box that holds numbers. So again, a number is going to be an integer if it's a whole number. So to declare a whole number integer value, we write the word int, which you probably remember from here, int main, which we'll get into why you need that again in future tutorials, but for now let's focus on this. And we're going to put a number in here, so let's call this variable number. Again, it's user defined. If I wanted to call it Jimmy, I could call it Jimmy. But you kind of want it, you know, it's convention to call it something that it represents, so we're going to call it a number. And that's going to equal the number 7, and you end that with a semicolon. Remember, no quotation marks right here, just the number. Okay, so that's another variable. Let's do the other two variables we did. Let's do let's make a variable that holds the name Bill inside. So to do that, we write string, because that's the data type. Remember, multiple letters is alphanumeric data is called string data. Okay, which, you know, I'll actually get into it later. String is technically a class, and I know you don't know what class is, so for now just know it is a data type for now. Okay, string data, and we're going to call it name equals double quotation marks Bill semicolon. Okay, so there's your variable for a name or multi-character data. Okay, now in string, don't get it confused with only being characters. If I wanted to do Bill 99 hyphen semicolon semicolon inside these quotation marks, that's fine. Alphanumeric data will hold all these characters, and this will not cause an error. This is everything you can keep in this variable. That is fine. So just know that. But for now, actually, let's call it Bill 99. Okay, so that you don't forget that you can actually put numbers in string. If you wanted to do just 99, you could, as long as you have the double quotation marks. It's still string data. Okay, so, but for now it's Bill 99. And then for the last data type, let's do a decimal number. Rich, remember I said it could be float or double, but for this class we're going to use double. So it's a double. Let's call it decimal equals 7.77 semicolon. And all this is fine. If we run this program, it will not cause any errors. Everything runs, process returns 0, same outcome. All this stuff is happening behind the scenes, so of course you won't see anything in the console window when we run it, anything different. You know, you'll still get the same result, process returns 0, everything's fine. But the point is to just show you how to declare these variables and data types, kind of discuss what they are, and show that, you know, if you declare them right, you won't get an error. Let me show you what will happen if you if you call this character, or let's say we call it string, okay, without the double quotation marks. If you declare it wrong, which this is declared wrong because you're calling it a string and you don't have your double quotation marks. If you want it to be right, you'd have to put in double quotation marks. But if you take those out, then this is declared wrong, and when you try to build and run, you'll get an error. See this red box? And then if you look down here in the log, you can scroll down and it says error, conversion from double to non-scalar type standard : string requested. And that build failed, one error. So that right there will cause the program to crash. So we need to change that back to double. And if we run it again, build and run, everything will go fine. So that's it for this tutorial. Let's move on to the next tutorial.
As you can see on screen, I've already got our basic code typed up, what we've been calling the skeleton. I do need to add a return statement, return 0, and for this tutorial, you know, I kind of want to go into, we're going to start with output, because output is going to be a little bit, we've kind of already seen it in the Hello World program. So in the Hello World program, we saw something along the lines of this. And when we ran it, the screen printed Hello World before we saw our process return to 0. Okay, so for now, we're going to go ahead and take out this endl right here, because I just want to focus on something a little bit easier, and that's just basic output, and then we'll go into basic input. So right now we're just going to see this right here, Hello World, and when we run it, you'll see a little bit of a difference, but not much. The only difference is there's not as much space here. It just says Hello World, and then immediately process returns 0. And later we'll get into why that's so when we took out that last code, but for now, let's just leave it as is. So what is this? Well, this is an output stream, cout. That's where the out comes from, is output. So when you use cout, you're referring to output to the console, and that's what the C stands for, console output. And the console is the big black window that pops up when we run our program. So when we say console output, and then these two operators right here, and then we specify a string, and this is a string because there's double quotation marks. We specify hello world, the console will actually output the word hello world, and that's exactly what happens. Okay, so you know, kind of just to show you, we can put integer, we can put an integer here if we want to. We could say output 9, and it'll output the number 9 on the console. Okay, so that's kind of basic output. But I kind of want to go into, I kind of want to throw in variables into this for a second. So in the previous tutorial we discussed, you know, the variable letter, you know, we'll call it the letter Z this time. Okay, so if we're wanting to declare a data type of one character, and we want that character to be the letter Z, we would do it as so. We'd specify char for character, and then we'll call it, you know, we'll call it anything we want. We'll call it, you know, we can call it letter Z equals, and then single quotation marks Z semicolon. So here's our variable right here. Well, if we wanted to output this variable, we would just say cout operator, and then we would type the name of our variable, letter Z. And if we run this, we'll get what you expect. We get the single character Z, because what this is saying console output the variable letter Z which we called letter Z, okay, output whatever this variable is holding, and it's holding this letter. And remember, just because we called it letter Z, let's call it something else. Let's call it let's just call it box, okay? Let's say we called this box, okay? Well, when we see out box, it's going to go to where we declared box at, which is right here, the variable box, and it's going to look what it's holding. Well, it's holding a character Z. So when we console output box, it outputs Z to the screen, and then process returns 0. Now let's back up for a second because I didn't really explain this. What are these right here? Well, these are what I call them stream operators. They're basically they're just the output stream, and what it is anytime you say cout and you're wanting to output, you can't just say cout box. That will return an error right there. That's an error. So what you do is you use a output stream operator, which is just 2 less than signs. So you have to say cout 2 less than signs, not this. It has to be 2 less than signs, and then box. And if we do, I kind of just want to show you, more for practice, and I really want you to do this on your own so you can see all the different possibilities. But if we do 2 of these lines of code right after the other, you're going to get just that. You're going to get 2 Z's one after the other. Okay? So I got 2 Z's because we wrote the statement twice. So that being said, let's try something here. So let's go into that right here. Endl, what is that? Well, that stands for end line, and this is used a lot with basic output because it gives you spacing. So if we do the output stream operator, which basically this is the same thing as saying cout box, console output, end line. This will work the same way. Z, and then you'll see there's a space here because we added a blank line. And if we do, so we could take this out, we could even add it right here. This is the same thing. If we just did that, we're using it all in one line of code. Basically, you're going to get the same exact result. So I kind of wanted to show you that there's many ways you can do this, and I really want you to play with this on your own because you're going to learn. You could say cout box, endl box, endl, and then when you run it, you get just that. You get Z, and then on the next line Z, and then a new line. But if you added another Z, you would get a Z right there. So it's kind of, you really just need to play with this output because you're going to get a lot of cool stuff. Let's move on below this. Let's leave that code there. Let's declare a new data type. Let's call it let's do a decimal value. So remember double, and we'll call it box2, the variable name, equals 89.47 semicolon. Oops. Semicolon. So there's our second variable. So let's add cout box2 endl. And let's run that. So what do you get? Well, you get your 2 Z's because you had box here, you ended the line. On the next line you put another box and you ended the line. And then on the next line you put box 2. Well, what's in box 2? 89.47. That's why you get 89.47. Then you ended the line and then you returned 0. Process returns 0. So you can see if you play with this, you're going to learn, and I want you to do it. I want you to go through, I want you to use different data types. This right now, if we just did, let's try another data type just before we end this tutorial. Let's do a string, and we'll call a string address equals 1400 College Drive. That's an address, and we had to use string because it's alphanumeric data, right? You know, if we wanted to use, we couldn't use an integer because it obviously has alpha characters in it too. So that's why we used string for the address variable. And if we wanted to output that, you know, we could do cout. We'll give it some space. We'll do 2 new lines, and then we'll say output address, and then add another new line, end line. Let's output that. Let's see what that looks like. So we get our 2 Z's, our box2 variable 89.47, and then if you look down here, we added 2 new lines. That's where the blank space comes in, and then we outputted the address. Oops. So then we output the address 1400 College Drive, which we declared in this string variable right here, and that's where that comes from, and then process returned 0. So there you go. I want you to play with this. I want you to try doing it with character data, integer data, string data, and double decimal point data. I want you to practice outputting everything that we learned here. You know, maybe try outputting your name and writing a sentence. You know, like maybe try doing you know, string name equals, and then put your name. So my name is Zach. And then try to output that. So be like, so end a line and then output name, and then output is teaching a class. Okay, and then end the L, end the line, and then output that. And look at what you're gonna get. You're gonna get a really cool output, because you're getting a name that you declared in this variable, string name. And you in that variable, you're declaring it as the name Zach, which is output right here. So you're saying, you know, console output my name, which we declared here, Zach, and then immediately after that, don't end the line or anything. You know, output this string that we're declaring as a raw string right here. This isn't in a variable. This is actually, we're just putting this straight into our output stream. Is teaching a class. And then end the line. So in the last tutorial, we discussed basic output. We discussed things such as, you know, if we declared a string with, you know, we'll call it name equals Zach, and then we would declare, you know, let's say an integer value, age equals 23. And then let's say we wanted to output that. You know, we could say something like console output cout, the 2 less than signs, you know, don't forget that. And then we could say name, 2 less than signs, and then is, that's gonna be a raw string that we are inputting into this output stream right here. And then less than, age, less than, years old. And then we'll even throw in a new line, end line right there. And when we printed that, you know, if you messed around with this enough, oops, so you saw an error right there. I'm getting an error, and the reason why is because I wasn't paying attention, and I'm sure you caught it as you were watching me, but this right here is an integer, and I accidentally put double quotation marks. So let's take away those double quotation marks, turn this into an integer. There we go. So now we shouldn't get an error whenever we build and run this. So I'm going to build and run it, no errors, and we get the output Zach is 23 years old. And if you practice this enough, this should seem pretty easy for you to understand. But let's move on to what we're talking about now, and that is input, console input. So if console output is cout, then what do you think console input is? Well, that's going to be cin. Okay, and then cout deals with less than. Well, cin deals with greater than. So if you look at the difference between these two, the stream operators. And right now, I know you're thinking, wow, I'm going to get those mixed up a lot. Well, believe me, I got them mixed up all the time when I first started programming in C++, but I promise you, after lots of practice, you will probably never ever get them mixed up again, because you'll get so used to using the right one. And this is going to have to be something that you practice a lot, though, because it's not something that you can get down, immediately. So you have to remember, CN is greater than, Cout is less than operator. So how do we use CN, though? Console input. Well, if you're asking, let's take this out real quick, okay? Actually, no, let's leave this up here. Okay, let's just give us a little bit more space. Let's give us another new line. And then let's do another name. Let's declare another variable. We'll call it string name2, and we won't give it an actual name. See how we have it up here? We have it declared as a Zach. We declared name as Zach. Right here we're declaring name2 as nothing. Name2 isn't holding anything right now. And so what we can do is we can say something like, we're going to output enter name2. So what we're going to do is basically we're going to have Zach is 23 years old output, and then below that we're going to get an output saying enter name2. Well, it's asking for you to enter something. So to enter something and to let the user use the keyboard to type in a value, you use CN greater than, and then the variable name that you want to hold the input in. So since we're telling them to enter a name, we're going to use this variable to hold the name that they enter. So let's say CN greater than name2. And what that's going to do is when the user enters in a name, it's going to store whatever he enters into the variable name2. Okay? And then we can say Cout. We're going to end a few lines. We're going to say you entered, and then name2 indel. And what this is going to do is whatever I enter in for this right here, CN name2, it's going to output you entered, and then whatever name2 is holding at that point. So let's test it real quick. Let's build and run this. So if you see, we get Zach is 23 years old. That is the result of this first declaration and output stream that we have going on in this first part of the code that we did at the beginning. But then it says enter name2, and you see a cursor blinking right here. And that shows that the console is waiting for input. So right now we're right here in the code, CN name2. So it's saying enter name2, and the console is waiting for us to input something, and then whatever we input, it's going to store it into name2. Okay? So if we enter, let's say, Jimmy right here, and I hit enter, they'll say you entered Jimmy, because right here we console output you entered, and then name2, and name2 is holding the value that we entered into it, and that's where it says you entered Jimmy. So what happens if we want to do something like int age2? Well, then obviously, since we're declaring age2 as an integer, whenever we ask for input, oops, I forgot to change this to age2. Let's build and run it again. And then of course right here, this needs to be age2. And that's where these errors are popping up. So fix that. Let's run it again. So it's asking enter age 2. Well, age we declared is an integer, so obviously we need to enter an integer such as 8. I'll say you entered 8. Well, what happens if we enter a character data instead, like B or B39, that's string data? I'll say you entered 0, because basically what's happening is that's not a valid data type, so it's giving us a garbage value right here. So anytime you get a weird value that's not what you're expecting, you might want to go look at your data types that you've declared and make sure that they're matching the input of the user. So what I want you to do is I want you to practice using the CN, console input, and maybe make you a little script or something, a little program that asks you what your name is, and practice entering it in with different data types. For instance, you could declare, character first initial, and then character last initial, and then say, console output enter first initial, and then you're going to do a console input first initial, and then see out, and then maybe give yourself some space with some indels in lines, and say, enter second initial. And then you're going to have to do another console input, CN, greater than last initial. And then say see out, and then give yourself some space and say, something along the lines of, your initials are, and then first initial last initial. And then if you run that, I'll say enter first initial Z, enter second initial R, your initials are ZR. You just kind of practice doing something like that, entering different data. Make sure you're declaring your data types right, and make sure you can mix your input and output and get everything right. Practice using these stream operators, because CN is using greater than, and cout is using less than. And I would say take a few hours, practicing this, and just doing different scenarios. Do your initials, a program that asks for initials, and then do one that maybe asks for your address and stuff like that, and just practice entering in data and matching it with your data types.
So to start off, I'm going to go ahead and assume that all of you have been practicing declaring your variables and whatnot. So I'm not going to explain that stuff in depth. I'm going to assume you already have this stuff down. So to begin, we're going to start with simple addition and subtraction. And I just want you to follow along, and you should notice that it's fairly straightforward. So you can start by declaring your variable as so. And then to use these two variables in an arithmetic, operation, you could do several things. You could declare a variable called result and hold the arithmetic value of the addition of num1 plus num2. That'll hold the value of this operation. So if we wanted to actually output that, we could see what the value is after this operation, and you should see that it's 11. As so. And the same thing if we wanted to do subtraction. You just add a minus sign, a hyphen, and when you output that, you should get -1. -1. So you can see that in C++, addition and subtraction are fairly straightforward. And I do want to show you a few things, with respect to hard coding values. So if we wanted to do num1 minus 4, we can do that. We can hard code the value in there in C++. That's fine. We'll get 1. And I also want to show you another output trick. If we wanted to just output the result of num1 plus num2, we can do that. We can output that result and we'll get 11. So there's lots of different things you can do with addition and subtraction. And all your basic order of operations rules do apply here. So if we wanted to output, you know, num1 plus num2, you know, minus 4, it's gonna do the order of operations to do this. So it's gonna start in parentheses, do this operation here, that'll result in 11, and then subtract 4 to give you 7. And we're just gonna output that all at once, and we get 7 as so. So I want you to play around with the addition and subtraction, and you'll find that it's fairly easy, and that there's lots of stuff you can do with it with respect to output and order of operations and hard coding values, etc. But let's move on to multiplication and division. Okay, so same thing with multiplication and division. We're just going to go ahead and put the whole operation in this output stream right here. So we're going to see out num1, and then for multiplication it's not an x as some of you may think, but it's actually an asterisk. So num1 times num2, which will give us 30 in this operation, and when we output we get 30. So multiplication is fairly easy, and you know, like I said, order of operations again applies here. So if we want to put that there and then plus 7, we should get 37. And I do believe if you remember this stuff from math class, you don't even have to have these parentheses here for this operation, because multiplication will come before addition. Multiplication and division first, and then addition and subtraction come after that. So if we run that, we will still get 37. You know, so it's different. It's not going to do num1 plus 7. You know, if we even put, just to kind of prove to you, if we put 7 plus num1, it's still going to do this operation first and then add 7. We'll get 37. So I just kind of want to show you the importance of order of operations in C++ because the rules still do apply. So let's do something like this. Let's change num2 to 30, okay? And let's try some division. In division, you would just do num2 and then the backslash is the division sign, num1. And if this works right, it's going to be 30 divided by 5, and it's going to output 6. So that's fairly simple right there. And you could do the same thing. Again, order of operations. You know, if I wanted to add 2 to this, we'll get 8 no matter where I put it. You know, I can't put it in between here, because if I do something, let's say I do something like this. Let's say I do, you know, num1 divided by 5 plus num1. That's going to be, it's going to basically do this first. Actually, let's do this. You know, this is a cool order of operations, because here you have addition, but you have division first. So you might say, well, division is going to go first. Well, that's not true, because parentheses goes before multiplication and division. So here, it's going to do this operation first, 5 plus num1. So that's going to turn into 10, and then it's going to do the division. So 30 divided by 10, and it should output the number 3. And if we run that, that's exactly what we're going to get. We're going to get 3. So this stuff, if you practice it enough, it's going to become fairly straightforward, and you're going to realize you can do a lot of cool stuff with this arithmetic operations. So one more main arithmetic operations I want to show you is the modulus operator, which is the % sign on the keyboard. And what this does, this returns a remainder value from a division operation. So just to kind of show you, we're going to change num2 to 11 and leave num1 at 5. And we're going to hold result equals num2 modulus operator num1. Now I want you to think about this. This right here, this operator is basically returning the value to hold in result of the remainder of the division operation. And if we divide num2 by num1, basically we're going to get 11 divided by 5. 5 will go into 11 2 times, with 1 being the remainder. So this operation will store the number 1 into result. And if we output result, you'll see, oops, hold on one second. If we output result, I think I hit the wrong key. Yeah, here we go. We get 1, which is the remainder. And I kind of want to show you that, if we do, also, all the rules apply. You can do, I'm sure this becomes fairly clear to you, but you could do result plus 4 right here. See how result plus 4, you can do, that's going to do 5. I just kind of wanted to show you that real quick. Okay? And, but going back to the modulus operator, let's do another, how about let's do this. Let's do 2 modulo operators in a row. So let's do, just so you can kind of see if you can guess what the value will be after this operation. Let's do the value 14 here, and let's output result modulus operator, modulo, whatever you want to call it, result modulo, let's do 2. Okay, so think about this. Result is holding the remainder of this operation, and then we're outputting the remainder of this operation. So think about that for a second, and I want you to try to guess what the output's going to be. Now, if you guessed 0, you're correct, because what's happening is result is holding num2 divided by num1 and the remainder, which is going to be 4. Okay, because 5 will go into 14 2 times with 4 left over. And then we're going to output 4 divided by 2 and the remainder of that. Well, there isn't a remainder of 4 divided by 2, it's 0, because 2 goes into 4 evenly. So when we output this, we're going to get 0. And it's that easy. Now, before we actually get into concatenation, which may sound like a difficult topic, which it's really not, I just kind of want to discuss this using namespace standard one more time with you guys, just to give you an idea of why it is in our code. And the reason why, I told you at the beginning of this series not to worry about it, and that the reason why we're putting it in our code is to make our lives easier. And I want to show you, it's because when we do something as simple as cout hello world, and we try to output that, if we don't have this using namespace standard, all of a sudden our code falls apart, and we get an error right here, an error, and it says error, cout was not declared in this scope. Well, without getting into too much detail, this namespace is including a function cout, the standard function cout, the output operators. So we need using namespace standard just to do simple, standard operations such as output hello world to the screen and then end the line. Now, there is a way to get around this, obviously. You could take this out and do something else to use this function, but I don't want to get into that yet because that's more of an advanced topic. I wouldn't consider that a good topic to discuss with absolute beginners in programming. That goes into using namespace functions, which I consider an advanced data structure. It's similar to a class in a way, which is going into object-oriented design, and that's not something I want to get into in this series with you guys, because I just want to cover all the basics, and then when you get this down, maybe in a future series we'll go over advanced data structures and object-oriented programming. But for now, we're going to keep it simple, and we're just going to keep using namespace standard in our code. That being said, let's move on to concatenation, which is a simple, and in my opinion, it's a simple topic, even though it sounds difficult. And all concatenation is, it's basically the addition of strings. And I want to show you what I mean. So if we do string first name equals Tom, and then string last name equals Jones, then we can actually outdo, you know, something like string full name equals first name plus, let's add a space in there, plus last name. And we can output that. We can output full name, and it will output Tom space Jones. Let's run it. And as you can see, Tom Jones appears in the console. So, that being said, that's basically all there is to concatenation. Now, there are a few rules. You know, if you mess around with it, you're going to find out you can't do stuff like output Tom plus Jones. When you output that, you get an error. So you need to have a variable in between your raw strings. You need to be adding a raw string to a variable when you do concatenation, either that or two variables together, if you understand that. And if you don't, I would say just practice this concatenation topic, and it will become simple to understand, you know, when you can use concatenation and when you can't. And just messing around with it, you should, you know, get enough errors just playing around. You'll say, oh, okay, I get what he's saying. You know, you have to have, you know, if I wanted to do output Jimmy plus last name, I can do that. I can say Jimmy Jones. But if I want to say Jimmy plus Jones, I can't do that. That'll throw an error. So that being said, that's basically all there is to string concatenation. There are some you know, built-in library functions that you can use, but we'll get into built-in functions later in this series. For now, I just want you to mess around with concatenation, and I wanted to just show you why we have using namespace standard in our code. So thank you for watching, and I'll see you in the next video. Now, if statements are a very important part of programming and C++ programming, because an if statement, I want you to think of it as a way for a computer to make a decision based on certain conditions being met. Meaning, if you think about like a small weather app, there might be an if statement that says, you know, if it is raining, then show a cloud on screen. But if it is sunny, then show the sun on screen. And that's kind of what an if statement is. It says, if this is true, then do this. And I want to show you that. I'm going to say if, and we're just going to put true in here, which is a Boolean variable. And we're going to go over that here in a second as well. We're going to say, this code is ran. Okay? Let's actually add an end line. And when we run this, it'll say this code is ran, because the condition inside these parentheses is true. And inside these parentheses is where you put your condition. So if we put false, okay, this code will not be ran. When we run it, you will not see this. It will just return 0. And just kind of show you, to kind of touch more on true and false, if you remember in one of the first tutorials over data types, we talked about Boolean data. And to do that, you type bool, because we're going to declare a Boolean data type. I don't think we actually did an example of Boolean data type, but I think we did discuss it maybe. And I'd actually have to check and look. But Boolean data is another data type that is either true or false. So we could say Boolean, you know, var1 equals true, and bool var2 equals false. And then we could actually put the variable in here, so we could say bool var1, and which is holding the value true, and this code will be ran. If we run it, this code is ran, as you can see. So you can kind of see in this tutorial, you know, along with if statements, we're also kind of learning about Boolean variables, which are a very important part of C++ programming as well, because all of these if statements are going to be focused on whether the condition inside these parentheses is true or false. Now that being said, you don't have to have Boolean data in here necessarily. We could actually do something like this. We could do int num1 equals 5, and we can say if 5 is greater than 3, then run this code. And this is the greater than sign, and if we do that, it'll say this code is ran, because actually I hard-coded 5 in here, but you could actually put num1 as well if num1 is greater than 3, and it'll say this code is ran. Same token though, if 5 is less than 3, which it's not, then this condition is false, because 5 is not less than 3. That returns false, so this code will not be ran. If we run it, you can see process returns 0. This output statement was not ran. So that's pretty simple stuff. You know, you can kind of make an if statement run based off of whether the condition inside here is true or false. And we're going to go more in depth with that later in this section when we make our own app, practical app that you could use. And I might even make some kind of number guessing game. I haven't decided yet. But either way, we're going to really show how we can use these if statements to make really nice flowing code that makes decisions based on user input. So that being said, what if we wanted to add another part of this if statement, basically saying, you know, if num1 is less than 3, we'll say, we'll actually say that, we'll say num1 is less than 3. But what if we want to say if num1 is greater than 3, we'll say num1 is greater than 3. Well, to do that, we put else if num1 is greater than 3, brackets, output, num1 is greater than 3. End line. And to make it more interesting, we're going to say int num1, and we're going to say enter a number, and then put that number in num1, and then depending on that will be what code is ran. So you can say when we enter a number, it's going to hold it in num1, okay, and if num1 is less than 3, this code is going to run. But else if num1 is greater than 3, then this code is going to run. Watch when we run it what happens. Enter a number. We're going to say 7. 7 is greater than 3, so this code down here should run, but this code right here should not. And when we hit enter, it says num1 is greater than 3, and only this code ran. And so to run multiple if statements together based on one calculation, kind of, you would use if and then else if. And then if you wanted to basically do a default, if all the above are false, you add else and then brackets, and then you don't add a condition to an else statement. This basically says if all else fails, if all these return false, then do this no matter what. So just kind of thinking about it, what would be the default? We could say, you know, if num1 is less than 3, do this. If num1 is greater than 3, do this. Well, otherwise, that would mean that num1 is equal to 3, right? So we could say else num1 is equal to 3. And to show you that, we'll run it, and we'll enter 3. And I'll say num1 is equal to 3, because basically we didn't even have to do a condition, because it knows. It says, well, the way we did it, the way we coded it, we said if this is false and this is false, then do this. You know, if all else fails, do this. And that's what happened. But at that same token, you really don't even need this else statement. If you just wanted to do another else if, you could say else if num1 equals, And this may seem confusing to you at first, but in an if statement, when checking if something is equal, you do need two equal signs. This may seem confusing at first, but it'll probably take a little bit of practice, but that's just how C++ and even Java is coded. You know, you do need two equal signs to check a condition inside an if statement. So that's why I have two equal signs here rather than just one, because that will actually return an error. So we need two equal signs here. So basically it's saying if num1 is less than 3, do this. Else, if num1 is greater than 3, do all this. Else, if num1 is equal to 3, then say num1 is equal to 3. And that's the same thing as just saying else, do this, because those are really the only three possible outcomes. But you can see if you had a whole bunch of different statements, how you might just want an else statement at the end to return a default value, such as, you know, for instance, there's really not anything that would run this code, so you would say you didn't enter a number, you know, because that's probably what would happen. In fact, I think if we entered a string, it would actually return 0. It would just throw 0 or a garbage value in num1. So let's see. Let's just run it real quick. If we enter 3 again, this code will run num1 is equal to 3. But let's see if we don't enter. If we enter something, let's see if we can try to get this code to run. Such as if we run, just type in star or something. It'll say num1 is less than 3. And the reason why it's saying num1 is less than 3 is because, even though we entered star, is because num1 is a garbage value right now. Because we entered star, and we're supposed to have an integer value inside num1, so instead it threw a garbage value in there, which is probably actually 0. It probably just defaulted to 0. And we can actually check at the end of everything. We can actually output after all these if statements num1. So if we type in something like Zach, says num1 is less than 3, and the reason why is because the default value for num1 just happened to be 0. That was the value in the memory address for num1, and that's why. So you can see how important it is that the user enters a number, because if he enters a string, then the first branch of code is going to get ran. This branch right here, which may not be what you want to happen. So it may, you know, may be a good idea in a program like this to put emphasis on number. You know, there's obviously other ways you could handle it other than just putting emphasis on that. For instance, you know, there's try and catch pieces of code, but that's all advanced stuff again, so we won't be worrying about that. But when you get into more advanced programming, you will be doing try and catch clauses and stuff like that, and catching your exceptions that get thrown for whenever the user enters wrong data. So that being said, that's pretty much all there is to if statements. You know, I do think it's a good idea for you to maybe go look up the operators that you can do. You know, for instance, if num1 is greater than, you can also do greater than equal, which means greater than or equal to 3. You can also do less than or equal, which basically if num1 is less than or equal to 3, it will say num1 is less than 3. If num1 is greater than or equal to 3, num1 is greater than 3. And let's just run that and see if both codes get ran, because basically if we enter 3, it'll say num1 is less than 3, because only this code got ran, but really it could have ran if we just had if instead of else if. Because if I put an else if, it's basically adding it on to these if statements. If we enter 3 again, I think all 3 of these will actually get ran. Let's check it real quick. I believe my debug, I believe it's actually froze, but I want you to play around with it right now, and just kind of look at all the different operators again. You know, another good one to look at is not equal to, exclamation point equal. That means not equal to. So if it says if num1 is not equal to 3, run this code.
Now I'm going to go ahead and kind of give you an example of what a switch statement looks like and then discuss to you how it works. So going to go ahead and type out everything. Right here is where the switch statement starts. Okay. Oops. You put everything in brackets. Go ahead and give you some room. And then you put your cases in. So here is our switch statement, the basic functionality of a switch statement. Okay, and I typed it out because I just kind of want you to follow along. It's going to be easier for me to explain it to you like this. So here we have a variable called grade, and our grade is a B, okay? And then below that we have our switch statement defined in these brackets right here, everything in these brackets, okay? So basically, to define a switch statement, you write the word switch, and then in parentheses next to it, you put the variable that you are analyzing. In this case, it's grade. So we put grade here. And then, in your brackets, you put your cases. So you put case, and then what you're comparing the grade to. In this case, we're comparing it to different letter grades. So the first one is case A. And here, you enter more brackets, and you put the code that you want for case A. So, you made a 90 or above. And then, on case B, you do the same thing. You can put your code here. You made a 80 or above. And you can repeat that for each of these, and I'm going to go ahead and do it here so that you get full visualization of how the switch statement works. Then case F. You failed. So basically, what's happening here is this code runs. We have a grade of a B, and then we look in the switch statement. We tell the switch statement to analyze grade, which is B. So right here is grade, the variable that we're analyzing. And we say, is it an A? Well, no, it's not. Is it a B? Well, yes, it is. So we're going to run this code. Is it a C? Well, no, it's not. Is it an F? Well, no, it's not. So this is the only code that should get ran. But I want to show you something real quick so that you can see what happens before I fix it. Let's go ahead and run this program. And you can see it says you made an 80 or above, you made a 70 or above, you failed. Well, that's interesting because we made a B. It said everything except A. But once it got to B, it basically did all the code below B. And that's because in a switch statement, you need to add a break. And to do that, after all your code, you say break. And you do that at the end of each case to tell it to leave the switch statement. Because switch statements have what I like to call a waterfall effect. Meaning if you don't put your break in right here on this code to break from this switch statement, then once this is true, it's going to waterfall down into the rest of the code, the rest of the switch statement code. So if we took out this break statement right here, it should run the B code and then run the C code before it breaks. And let's check it out. As you can see, it said you made an 80 or above, you made a 70 or above because it didn't break from the switch statement until it got right here. So what we need to change is, of course, if we just add a break here, you'll see that it says you made an 80 or above because our grade is a B. And just to kind of show you how we can further this, let's do grade, and then we'll say something like enter a grade, enter a letter grade, okay? And then let's use CN to hold our grade. And then let's watch how this switch statement is used. So enter a letter grade, we're gonna enter F. It says you failed because basically it went through the switch statement, it put the grade that we entered in here in the switch statement, analyzed it, looked for the case. Is it an A? No. Is it a B? No. Is it a C? No. Is it an F? Yes. You failed. And that's how a switch statement works, okay? So let's run it one more time. We're gonna enter in, let's enter in an A. It says you made a 90 or above. So that's the basic functionality of a switch statement. And you can see how it's very similar to an if statement by checking which condition is met. And like an else statement in an if statement, a switch statement also has something similar to else, which is called default. So if we wanted to take out this F, we can just say default you made an, or you failed, which is the same thing as saying is if none of these are true, then obviously he failed. Let's go to the default switch statement, which is he failed. If we run that and we enter in an F, or let's even enter in a D, it'll say you failed, because if we enter in a D, obviously A, B, and C aren't a D, so it's going to go to the default and just say you failed. But you know, obviously if I enter a Z, that same code is going to run because it's neither A, B, or C. So if you wanted to restrict the user to only entering the correct letter grades, what you would probably want to do is say something along the lines of case F, and then output you failed in line. And then on the default, you could say something like you entered an invalid letter grade. And now when you run the code, if it's not A, B, C, or F, if you enter something like R, it'll say you entered an invalid letter grade because it's going to the default. Let's go ahead and begin. And the way I want to structure this is basically we're going to make a calculator that lets the user decide at the very beginning if he wants to do addition, subtraction, multiplication, or division. And to do that, we're going to use a switch statement. Okay, so let's go ahead and structure it as so. We're going to write switch, and then there we go. Sorry about that, guys. The rest of my brackets got deleted. So there we go. Let's write it just like that. And make sure you get your return statement. Okay, and then in this switch statement is going to be the variable that we're checking. And the way I want to do it is I basically want to have the program open up and have numbers 1 through 4. It'll say 1 addition, 2 subtraction, 3 multiplication, and 4 division. And so to do that, we're going to hold a variable. So we're going to say int, and we'll call it choice. Okay, and we're just going to leave it like that. We're going to say cout enter a choice. Actually, the way we're going to do this, we want to let them know beforehand what their options are. So we'll say 1 addition, okay, in line, 2 subtraction in line, 3 multiplication in line, and 4 division in line. So this is what they're going to see. They're going to see basically this on screen, and they're going to have to make a choice on what they want to use. And then what we'll do is we'll say at the very end, let's give a little bit more space, and we'll say enter a choice. And then we're going to hold that with a cn statement in choice, our variable choice. So kind of, if you need to, push pause and kind of breathe all this in, exactly what we're doing. This is all stuff we've covered in the previous tutorials, and it should be fairly straightforward to you at this point. So at this point, we're holding the integer of the choice that the user selected into choice. So what we do is, in switch, we need to put the variable that we're analyzing, which is our choice variable, and then make cases. So obviously, we'll have case 1, case 2, case 3, case 4. And let's go ahead and add a default as so. Okay? And obviously, the default, we can go ahead and add something like exiting, you entered an invalid number. As so, because basically we're going to say if they don't enter 1 and they don't enter 2 or they don't enter 3 or they don't enter 4, they entered something else, and we're going to say exiting, you entered something invalid, and then it's just going to go straight to this code, return 0, and the program will end. So that's how we're going to handle that. Now in these, let's go ahead and, just so we don't forget, we're going to add brackets to all of these, as so. That way these are formatted nice and easy so that we can see, you know, case 3 is going to be right here, case 4 is going to be right here. And we're going to go ahead and add our break statements so that we don't forget, because that's going to be very important. These break statements are very important for this code, the way we're structuring it, because you don't want multiplication and division to be run on at the same time. So let's go ahead and add our break statements, which is a good practice to do with switch statements so you don't forget. I would recommend always adding your break statements first if they're necessary. So there we go. So as you can see, if you need to push pause and kind of look at this and make sure you have everything right, go ahead and do so now, because this is how our program, our calculator, is going to be structured. Is that so, with a switch statement? Okay, so that being said, now that we have our choice entered, basically everything is going to be the same at this point. So we'll say, right here, we'll say enter number 1, and just at the top, let's go ahead and add our new variables. So we have choice here, and you may see people do it a different way, but the convention that I learned in school was to always declare your variables at the top of your main function, or at the top of any function that you're in for that matter. So that's what we're going to do, just so you can get in a good habit of doing it. Let's give us a little bit of space. So we have int choice for our switch statement, and then we're going to use doubles in case they decide they want to use floating point values for their calculations. So we're going to say double number 1. Oops. And then actually, before putting our semicolon here, I want to show you something else. We're going to say number 2, which is a new way. This is another way you can declare your variables. And this basically says double number 1 and then double number 2. You can declare them like this. This is saying both of these are doubled, and we're not initializing them to anything. We're just making 2 variables of the data type double. So you can try that out, and again, it's a convention. You could just write double number 2 down here if you wanted, but it's all a matter of preference. So we're going to leave it like that for now, and then we're actually going to add one more thing. We'll leave that just like that. Actually, we're going to say on each of these, we're going to have them enter the number 1 and the number 2, so the code's going to be pretty repetitive actually on each one. So we'll say cout enter number 1, okay, and then cn number 1, okay, and then we're going to give a little bit of space, and we're going to say enter number 2, and we're going to get the input for number 2. okay? And then we're going to output, we're going to give us plenty of room, okay? And we're going to tell them the result. We're going to do it like this, just so you can see, so that the numbers don't run off the board. We're going to say result equals, okay? And then we're going to say, since case 1 is addition, we're going to say number 1 plus number 2, and then break. And this code is going to be pretty repetitive. So if you want, you can just copy this, because like I said, it's going to be the same for each one pretty much. And we'll paste it in here. Okay? Make sure you fix your formatting if the copy and paste messed up. But remember, case 2 is subtraction, so the only one you're really going to have to change is this. Change that to a minus. Case 3 was multiplication, so you'll just have to change this addition to a multiply sign. And then case 4 was division. We'll change that to a division sign. So there you go. So now our program should run just like we want. We got our switch statements and everything how it needs to be. Go ahead and save it. We'll say build and run, and let's see what happens. So there we go. As you can see on screen, we have our choices: addition, subtraction, multiplication, and division. Let's go ahead and enter subtraction. I'll say enter number 1. So let's do 5, enter number 2, 3. I'll say result equals 2. The process ends. That was subtraction. Let's go ahead and do division. 4. And I'll say enter number 1. And I kind of want to show you something with division, because I don't know if we went over this in arithmetic, but let's say I do 9, okay? And then we do, for number 2, we do 4, so that'll be 9 divided by 4. Obviously, there's a remainder there, but in just straight division, it's not going to give you the remainder. It's just going to give you 2 because it goes into it 2 times. Now you can see that the result is 2.25, and this is an interesting topic. If you practiced your arithmetic, the reason why we're actually getting a decimal, the actual answer, is because we're doing double on double division. So we have, since both of these are doubles, the result's going to be a double. But let's change these to integers for a second. We're going to do that same problem there. We're going to do 4. We're going to do 9.